So scientific notation is very important. It's a very good life skill because anymore we have lots and lots of really big numbers and lots of really small numbers, and it's nice to have a shortcut way to write those. I am looking around for a calculator. I'll show you how to do these on your calculator as well. So the definition for scientific notation is just a special way that we have to write very big and very small numbers. You've probably come across it in a chemistry class, for instance. So what you start with is some number, and then it's times a power of 10. And the caveat is that n, that number that's multiplying, has to be less than the number 10 and greater than equal to 1. Okay. So n is some real number that we know times a power of 10. Okay. And m can be any number. But for us, it will be an integer. And integers, right, are our whole numbers, but they can be positive or negative. Okay, so let's go ahead and do a little warm-up, kind of reviewing our exponent properties. So I have 10 cubed. What is that the same thing as? So 10 cubed, 10 to the m, right? M is 3. So, right, that exponent tells me how many factors I have. 10 times 10 times 10. And 10 times 10 times 10 is 1,000. So 10 cubed is the scientific notation way to write 1,000. 10 to the 5th. 10, 10, 10. 5 of them, right? So you might have done this, right, when you learned how to multiply tens. 1, 2, 3, 4, 5. 5 zeros. 1, 2, 3. 100,000 it looks like. Oh, 10 to the negative 2. What should we do about that? Well, right, we have an exponent property that says negative exponents, send the base below, make it a positive exponent, 1 over 10 squared. 1 over 10 times 10, 1 over 100. As a decimal, right, 1/100th, 0.01. So tenths is the first place. Hundredths, oh, I'm not going to fit that. Hundredths is the second place. Thousandths, 10 thousandths, etc. Okay, so let's go ahead and take a look right here. I scrunched it in, I guess. So 2,000. The number 2,000 is 2 times 1,000. And 1,000, we just learned before, can be written as 1,000 is 10 cubed. So 2,000, this is called decimal form. In decimal form, just the regular old way, is it written as 2 times, and typically we write the X for the time symbol. This is the only time we do it anymore. 2 times 10 to the third. So 2,000 is 2 times 1,000, and 1,000 is 10 to the third. And how about this? 0.003, so 3 1,000ths, 3 thousandths, is 3 times 0.001, which is 1 over 1,000, and that, right, 3 times 10 to the negative 3. So I will do it that way for a couple more times, and then I'm going to show you my shortcut. I call it the scoop method. Okay, so 4,100,000. 4.1 times 10 to the, well, gosh, maybe I have to do my scoop method right away. So it would be 4.1 times a million, right? So maybe you just know the scientific notation way to write a million. What I would do is go 1, 2, 3. So I put my pencil where the decimal currently is in this decimal number right here, and I swoop until I get to, I'm going to swoop until I get to a number that's greater than or equal to 1, but less than 10. And I'm counting how many times I swoop. So here we go. 1, 2, 3, 4, 5. 5 gets me to 41. 6 swoops gets me to 4.1. That's a number between 1 and 10, right? And it was 6 swoops. So that 6 is the power of the 10. So 500 in scientific notation. So 5 times what power of 10? 5 times 10 to the 2. In fact, you can start how I did. On this next one, what's the big N value? What's the number part going to be? Exactly, 7. 7 times 10 to the something. And so we're going to swoop until we get to the number 7. Now, what's different about this third example, though? Exactly, I have a very small number, right? I have a decimal version. So that means my exponent is going to be negative. So as I swoop to the right here to get to my number, that means my exponent is negative. Here we go, I'm going to count my swoops. 1, 2, 3, 4, gets me to 0.7, right, if I left my decimal there. I need to get to 7, that was 4, 1 more. 5, but since the number I started with is very, very small, that means it's a negative 5. 7 over 10 to the 5th. Okay, what's going to be the number part on 0.0378? Yeah, so 3.78. It doesn't just have to be one number out there. You can have decimals that come after. But I stop, right? I'm looking for the number in here that's between 1 and 10. So 3.78 it's the only way I can do that. And now I have to find the correct power of 10. So this number I'm starting with is less than 1. So my exponent will be negative. Put your pen where the decimal starts and swoop till you get to the number you wrote. 1, 2, 3.78 times 10 to the negative 2. Okay, so now let's try writing the other way. If I have 4 times 10 to the 5th, how do I write that in decimal notation? So, again, I use a swoop method for this. I just find it the easiest way. So I write the number I'm starting with, and I'm going to put it's a dot, it's not really a dot, but that's where my pencil's going to start. And I'm going to swoop 4 times 10 to the 5th. 5 is positive, right? So I'm going to have a big number. So I'm swooping to the right to create a big number, and I'm going to swoop 5 times. And those swoops create troughs. So 1, 2, 3, 4, 5, and stop. That's where the decimal now lives. And then each of those troughs I fill in with zeros. 1, 2, 3, 5. 5 zeros. Yes, I know I should just count the zeros. For some reason, I'm unable to think that way, and I have to do my swoop method. If you can, awesome. 1, 2, 3, and there's my comma, so it's 400,000. 4 times 10 to the 5th is, right, the much shorter way to write 400,000. This next one, 6 times 10 to the negative 2, it's a negative exponent. So I have a small number here. 6, decimal where it starts. And I'm going to swoop 2, but this time I'm going to swoop left to get me a small number. 1 for the 6, and then 1 more, and there's where the decimal ends up. And fill in the trough with a 0. Absolutely other ways. You could write this, right? 6 times 1 over 100. Maybe that's how you like to think about it. 4 times 100,000. Maybe you just know that 10 to the 5th is 100,000. That's great. 1.7 times 10 to the 3rd. 1.7 and 3 swoops. 1, 2, 3. I'm looking for a big number because my 3 is positive. Fill in your swoops with zeros. 1,700. Okay, so that's doing some converting. The next thing we can do is do some arithmetic with numbers that are written in scientific notation. So it all starts off great, but then we kind of have to pay attention at the very end. Okay, so I have 3 times 10 to the second times, right here's my other times if you want to actually put a little time symbol in there, 2 times 10 to the sixth. Everybody's multiplying, so we know from before in our lives that we can rewrite and reorder. So I'll put my non-powers of 10 together and my powers of 10 together. And now we're going to have to call on some exponent properties we know. So 3 times 2, that's just going to be 6. I'll hold that for a second. And now I'm here, I have 10 squared times 10 to the 6th. I'm multiplying like bases. So what did we do to the exponents? Exactly, we add them. So that's going to be 10 to the 2 plus 6, looks like 10 to the 8. So 6, I'll go ahead and do my x again, times 10 to the 8th. The number in front is between 1 and 10, so I don't have any little finagling at the end, right? I don't have to do any extra tidying to make sure my answer is also in scientific notation. But that's not going to be the case down here on this next one. So let's take a look. 6.2 times 10 to the 23rd times 2 times 10 to the negative 6. Okay, so let's rearrange again. So 6.2 times 2 times, oh, I was going to write my time symbol there, times 10 to the 23 times 10 to the negative 6. Better put some parentheses here. It's starting to look too confusing even to me, and I'm writing it. There we go. So 6.2 times 2, 12.4. And here are my like bases, multiplying like bases, add the exponents. Oh, that one's a negative. Oh, okay, well let's think about that. So I could take this 10 to the negative 6, move it below, and then subtract my powers, 23 minus the 6. Or, notice that's exactly what's going to happen here. Multiplying like bases, add the exponents. Well, 23 plus negative 6 is the same thing as 23 minus 6. So there are always options. So I have 23 minus 6 looks like 17. So 12.4 times 10 to the 17, right, which is correct. That is a correct answer. However, it is not in scientific notation. So I need to be, why is it not in scientific notation? Do you see why? This 12.4 is not between 1 and 10. It's too big. So I need to get this to be 1.24. So 1.24 times 10, right, would get me back to 12.4 times 10 to the first, right? And then I still had my times 10 to the 17th. So 12.4, let me find a color here. 12.4 is 1.24 times 10. And 1.24 is the number I need in front. And now exponent properties, 10 to the first times 10 to the 17th. Multiply like bases, add the exponents. So at 10 to the 18th. So altogether, final answer, big smiley face, 1.24 times 10 to the 18th. Let's punch that in there. Okay, one more example where we're going to use that property at the very end. You ready? Okay, so 1.4 over 7. Well, what are some ways I could do that? Here's what I was planning on doing, is doing the division and coming up with a 0.2. So we'll go ahead and do that way. So option 1 was my first thought. 0.2 for the 1.4 over 7. And then I have times 10 to the third times, I'm going to go ahead and bring this 10 to the negative 5 up, 10 to the positive 5, 0.2 times 10 to the, multiply like bases, add the exponents, which is an okay answer, but 0.2 isn't between 1 and 10, it's too small. So what I would do is I would borrow one of these 10s, 0.2 times 10 to the first times 10 to the 7th, right, so my 10 to the 8th, I'll split one of the 10s off, here's my 10 to the 7th, and then 0.2 times 10 is 2 times 10 to the 7th. That was my first thought when I wrote that question. What I saw when I was just getting ready to get into it was something entirely different. Okay. So option 2, and I'm not going to probably have room to finish it, was I would have stolen one of these 10s from the top first. So 1.4 times 10 times 10 squared over 7 times 10 to the negative 5. And 1.4 times 10, right, would get me to 14. So those two together become 14 over 7. Okay, so there's the 2. And now I have 10 squared divided by 10 to the negative 5. Oh, it looks like it's going to fit times 10. Show you something new here as well. Power of 2, or dividing bases, subtract the exponents. So this 2 minus this negative 5. 2 minus negative 5 plus a positive. 2 times 10 to the 2 plus 5 is 7. Okay? You can get it either way. Now I said I'd show you how to do this on a calculator, so I'm going to put the calculator up here and see if I can get it to focus in. And I'm just going to use TI-30 and turn it on. So scientific notation, right here is one of them. So there's the blue second key, and even if you have a different calculator, you probably have a little second button up top here. And then right below it, it's a button that says log. And right above the log, in a slightly different color, it has a 10 and it's raised to the x power. Okay. So if I wanted to do, let's just do that last example. It was 1.4 times, so to get to the, it's not on the actual key here, but it's above it. That's a second feature. So I'll do the second button first and then the LOG button. And notice how it's prompted me. It has a times symbol, and then 10, and then it's raised to that little caret key right here as well. You can see it on the screen maybe, although the glare looks pretty awful from my vantage point. 10 to the, and it was to the third power. Okay? And then close off your parentheses. And then divided by, now here's a tricky part. It's that 7 times 10 to the negative 5. Well, there's a multiplication inside my denominator. So I need to make sure that my calculator does the multiplication first, and then all of that is under the fraction. And I do that with these parentheses. So divided by 7 times 10 to the, so negative 5. You can't use this button over here. It'll yell at you. So use this change sign down here at the very bottom. The little minus sign in parentheses. So negative 5. Close parenthesis for the power. Close another parenthesis. And enter. Oh, and it didn't even put it in scientific notation. It's probably up here somewhere, but I don't know how to do it that. But so we'll just count. I have 2 times 10 to the 7th. So 20 million. Or 7 zeros. Can we count 7 zeros there? 1, 2, 3, 4, 5, 6, 7. 7 zeros. All right, so there's the scientific notation button on your calculator.